Dear Sir, Madam, Lady, Gentlemen, Professor, Researcher, and everyone here, today I'm very honored and happy to present my research, a novel collaborative fusion algorithm by mid-mining brain item set. I'm Professor Dr. Lộc Nguyễn from Vietnam, and this is my own company, Sunflower Soft Company Vietnam, and this is my email and my home base, and I'm honored and happy to make connection with all of you. And now I begin my presentation. Abstract collaborative filtering CF is a popular technique in recommendation study. Concretely, items which are recommended to users are determined by surveying her or his communities. There are two main CF approaches, which are memory-based and model-based. I propose a new CF model-based algorithm by mining fluent item set from rating database. Hence, items which belong to fluent item set are recommended to user. My CF algorithm gives immediate response because the mining task is performed at offline process mode. I also propose another so-called Rodner algorithm for improving the process of mining print item set. Rodner algorithm is implemented by heuristic assumption. The larger the spot of an item is, the higher it is likely that this item will occur in some print item set. It models up on doing whitewash task with grounds a corner on a wall in such a way that is um, capable ca- uh, cap, capable of picking different item set. Moreover, I provide enhanced techniques such as bit orientation, bit matching, and bit mining in order to speed up recommendation process. This technique the techniques take advantage of bitwise operation and are so as to reduce storage space and make algorithm run faster. Table contains one introduction to a new CF algorithm based on mining print item set, mining print item set, evaluation and discussion, and fifth is the conclusion. One introduction. Recommendation system recommend user favorite items among a larger number of assigned items in database. Item refer to anything such as product, service, book, and newspaper. It's expected that users are most interested in recommended items. There are two common trends: content-based filtering CBS and collaborative filtering CF in building up a recommendation system as follows. The CBS recommends an item to user if such item has a similarity in content to other items that he likes most in the mass. His rating for such item is high. Not that each item has content with its property and so on. Items will compose a matrix called item content matrix. The CF, on the other hand, recommended an item to user if his neighborhood are other users similar to him are interested in such item. Users rating on any item expresses his interest on that item. On ratings on items will also compose a matrix called the rating matrix. Both CBS and CBS have their own strong and good points. CBS focuses on item contents and user interest. It is designed to recommend different items to different users. Each user can receive a unique recommendation, and so this is a strong point of CBF. However, CBF doesn't tend to work community like CF does. If items that user may like are hidden under his community, CBF is not able to discover such illicit item, and so this is a quick point of CBF. Moreover, if the number of users is huge, CF may give a wrong prediction where CF will get an increase in accuracy. If there are huge contents associated with items, CF will consume much more system resources and process time in analyzing this item, whereas the CF does not encounter the problem of richness in item contents. CF only works on the user rating of items instead, which is now a strong bond of CF. However, this also implies the weak bond of CF because CF can make unexpected recommendation in some situations in which items are considered suitable to user but they do not relate to user profiles. In fact, when many items are not rated, rated matrix is turned into spare matrix which contains various missing values. The quickness of CF becomes more serious in case of spare matrix. There are two typical approaches to alleviate this weakness as follows. The first one combines CBF and CF called combination approach. In typical scenario, the technique has two stages. Firstly, it applies CBF into completing spare matrix, and secondly, it applies CF into making reduction for recommendation. The technique improves accuracy of prediction, but it consumes much more time and resources because the first step lays the ground of the processing step, and there is a requirement of both item content matrix and rating matrix. The second one compresses spare matrix into a representative model, which then is used to make recommendations. This is a model-based approach for CF. Note that CF has two common approaches, such as memory-based and model-based. The model-based approach often applies statistical and machine learning methods into constructing representative model. Ontological approach does not give such a precise result as a combination approach does. It can solve the problem of user database and spare matrix. Moreover, it can respond user requests immediately by making prediction on representative model to instant inference mechanism. In general, there are four common approaches for model-based CF, such as clustering model, latent model, markup decision offset model, and matrix factorization model. Clustering CF is based on the assumption that users in the same group have the same interest and so they create items. Similarly, there are two clustering techniques using clustering algorithm as the k-mean or k-centroid, and using Bayesian classifier. Author Miyahara and Basani proposed the simple Bayesian classifier for CF. Simple creating value runs in the integer interval 1, 2, 3, 4, 5, the set of some class. The simple Bayesian classifier uses naive Bayesian classifier method to determine which class is a given user belongs to. Other than that, assumes that there is a linear mapping from latent space of user and item to numerical rating scale. Such mapping which confirms the full zone distribution over on ratings construct a Bayesian network. Parameters of zone distribution are learned from training data which are used to predicting active user ratings. According to Campos et al., the hybrid recommenders models is the Bayesian network that includes three main kinds of nodes, such as the feature nodes, item nodes, and user nodes. Each feature node represents an attribute of item. Active user rating are depend on these nodes. Given a set of user U, U1, U2, UM, and a set of item I1, I2, IN, observation UI where the pair U and I is considered as the co-occurrence of user and item. The latent last variable C is associated with its co-occurrence UI, and we have a latent last variable C. The mapping UIC is called the latent last model for expert model. The problem witness to solve is how to specify the latent last model. Arthur Huffman proposed expectation maximization EM algorithm to determine which latent last C which is the most suitable to the to be associated to the co-occurrence UI. Similarity matrix has a significant growth and column dimensionality reduction aims to get rid of such redundant growth or columns so as to keep principal growth columns. As a result, the dimension of rating matrix is reduced as much as possible. Because of this approach pays attention to analyzing matrix, it can be called a matrix factorization approach. There are two well-known dimensionality algorithms such as the singular value decomposition (FVD) and principal component analysis. BCA. Given matrix M, the SVD approach the decomposer into the partial matrix U, U sigma V, so that M is the product of them here. U and V are called the user feature matrix and item feature matrix respectively, and sigma is a diagonal matrix of Asian values. In study FCF, SVD is approximated by two ways. Only after largest Asian values are used to compose matrix sigma, and so matrix U sigma V becomes smaller. The objective function is established based on the sum of square error between existing rating and predicted rating. Matrix U sigma V are parameter of such objective function. The ration approach, descent ratio is used to adjust this parameter so as to minimize such objective function. This method is developed by author Simon Front and Genevieve Urgel. It is also called the incremental SVD. According to Sunny et al., recommendation can be considered as a sequence process in multi-many state. At each stage, a list of items which is determined based on last year rating is recommended to user. So recommendation task is the best action that recommended system must do at current stage so as to satisfy user interest. The recommendation becomes the process of making decisions so as to choose the best action. After Sunny et al. Proposed markup decision process MDB to perform recommendation class MDB is represented as for type model SART, where SART are a set of states, a set of action, require function, and transition probability density function respectively. The action of making decision set is to find out the optimal policy with regard to such for type model. Note that policy is defined as the function that assigns an action to the assumption state. In this paper, I am to propose a new approach for model-based CF in which users budget pattern are mined and modeled as a frequent item set, which in turn are used to make recommendation system and make recommendations. It's an efficient approach because it takes advantage of data mining, needing to get fastest bit and high quality of recommendation. Although there are many researches focusing on model-based CF, the method to mine the association clues for CF proposed by author Xu et al. is nearest to the CF algorithm. In this paper, the author Xu applies shortest path algorithm to graph theory into finding distance between web-based. With not that these items are derived from you access sequence. Association clues are mined based on such distance that apply into CF. The core of the both CF is bit mining to discover frequent item set mentioned in section 3. It is required to do a survey bit mining. The term bit and binary have the same meaning in this paper. Author Dong et al. Robust so-called bit table FI algorithm. This algorithm uses data structure bit table to horizontally and vertically compress database for generating candidate item sets and counting that spot in which it goes in bit table corresponding with a transaction in purchase database is a string of bits, and each bit 0 or 1 indicates whether or not an item is purchased. Author Song et al. Propose a so-called index bit table FI algorithm which takes advantage of bit table. According to Song et al., given a bit table, index array and corresponding computing method are proposed. By computing the subsim index, items in accordance with represented item can be identified quickly through using breadth-first search at one time. Then for the resulting item sets generated by index array, that first search strategy is used to generate all other frequent item sets. Concept of index arrays is the core of index bit table FI algorithm. This algorithm runs significantly faster than traditional bit table FI algorithm. Bit table and index bit table contains a fixed bit vector. Alternatively, Arthur et al. Proposed dynamic bit vector. approach for fast mining brilliant to know the item set. Firstly, the author var et al. Use the lookup table to calculate the support of item set fast. Secondly, the author var et al. Propose a subsumption concept to save memory and computing time. As a result, the approach is more efficient than time algorithm in both mining time and the memory usage. Authors et al. Propose a so-called AMFE algorithm based on the breadth first of search crew equivalence lattice combined with compressed vertical binary representation of dataset. The binary representation and equivalence lattice make the algorithm run faster. AMFE is not closer to the bit mining in this paper because the action of AMFI is to take advantage of breadth first and equivalent lattice. After Reza et al. Proposed a so-called CBT-FI algorithm following a binary property, but such algorithm lost several transactions into one and forms a compact bit table so to reduce the memory consumption and frequency of checking item set. Compact bit tables is the most significant aspect of CBT-FI algorithm. Arthur Kirley et al. Proposed an abbreviated algorithm, but they take advantage of bit table representation of dataset given to matrix of proven item set. The algorithm run take Hadamard product of this matrix into matrices in order to generate candidate proven item set. Arthur et al. Proposed so-called MFI test attributes algorithm to mine the proven item set over online data streams with a transaction-centric sliding window. The idea of sliding window is significant. The W9 transaction-centric sliding window denoted test attribute in which W transaction given item S is represented by a WN bit set. If S is in the I transaction, the I of bit set of S is said to be 1. The MFI test attribute has three phases such as window initialization phase, Windows sliding phase, and proven item set generation phase. In the window initialization phase, trans attributes is created from combined transaction given a redefined length W. The Windows sliding phase is activated when trans attribute is full. At the time the new combined transaction is added to trans attribute and the old transaction is removed based on the bitwise left shift operation. Finally, in the proven item set generation phase, MFI trans attribute algorithm uses a bitwise operation to generate candidates item set and find proven item according to a property. Arthur Bashir et al. Built up lexicographic tree of items in transaction database. Item set generation is done according to lexicographic order and bit vector representation with attention that transaction database is taken from the into bit table. In a vertical bit vector representation, if item I is in transaction J, the bit J of bit vector I is said to be 1. Moreover, the authors Bashir et al. Propose a so-called projected bit regions (BBR) to gain efficient projection of bit vectors for calculating blocks of item set. BBR and lexicographic tree are significant aspects of the research, with least 2 of 3 the highest bit in mining proven item set. When compared with other research on bit mining, the proposed heuristic mining algorithm is seamless one in which there is no requirement of complex structure and complicated computation. In other words, its strong point is based on its simplicity, in which that we need to do in which cloning bit set with bit operation and result. It gains a high speed until it can lose some proven item set. Note that bit mining serves the CF application mentioned in section 2. And only optimal proven item set is used to generate recommendation list, so it is not requisite for it covering on proven item set in the most accurate way. This research consists of 5 sections. In section 2, I propose a new model-based CF algorithm based on mining fluid item set. The heuristic mining algorithm is discussed carefully in the section 3. Section 4 is the evaluation. Section 5 is the conclusion. Note that terms such as rated matrix, dataset, and database have the same meaning in this paper. Section 2, a new CF algorithm based on mining fluid item set. Section 2 and Section 3 is the main contents of my research. Given rating vector user, item 1 to item 2, 5, item 3, 2, indicates that user rated on item 1, item 2, and item 3 with values 3, 5, and 2 respectively. The robust CF algorithm based on mining fluid item set consists of two following processes. Most process is performed in a mock in which a set fluid item set as is derived from rated matrix. Recommendation process whenever user requires recommended item a fluid item set SE chosen from S so that S contains item 1, 2, and 3. For instance, S item 1, item 2, item 3, item 5, item 7. The addition items 5 and 7 are recommended to user. This process is performed in online mode. Although the modern process consumes much more time than the recommendation one does, executed in offline mode, and so it does not cause any negative time consuming impact on recommendation process. However, a serious problem is arises when the fluid item set as item 1, item 2, item 3, item 4, 5, item 7 did not indicate the rating values assigned to item 1, 2, and 3. Is it know that item 1, 2, and 3 are rated by values 3, 5, and 2 respectively in rating vector U. It means that rating vector U and fluid item set S does not match exactly. This called another hazard to predicting missing ratings. Concretely, it's impossible to estimate the rating values for item 5 and 7. The problem will be solved by using a so-called bit transformation technique. For instance, a rated matrix is where it grows indicates user, each column indicates items, and each cell is rated with a user gives to an item. Suppose the rating sequence in integer interval 1, 2, 3, 4, 5, where 5 is the most varied and 1 is the most disliked. The same rated matrix is shown in table 1. Table 1 rated matrix. Each item is split into 5 sub-items which are related to 5 possible rating value 1, 2, 3, 4, 5. Each sub-item is symbolized as item JK carrying two binary value state 1 and 0 and 1 and 0, which indicates that where the user creates on item J with concrete value K. For example, the bit sub-item item 2, 5 get this state 1 so that user gave a rating value 5 on item 2. Now the rating matrix is transformed into bit create matrix in which each cell is creating of bit sub-item. If a cell gets state 0, there is no one giving a rating on such cell yet. The bit creating matrix is shown in table 2. Table 2 bit creating matrix. The fluent item set, which is extracted from bit creating matrix, carries a so-called bit from S. Item J1 K1, item J2 K2, item JM KM. Each element item JK is defined as bit sub-item. Rating vector is also transformed into bit rating vector U. Item J1 K1, item J2 K2, item JN KN. Thus, it is completely simple to match the bit fluent item set as with the bit creating vector U. For instance, the creating vector item 1 3, item 2 5, item 3 2 is transformed into user item 1 3, item 2 5, item 3 2. Whereas the bit fluent item set S1, item 1 3, item 2 5, item 3 2, item 4 5, and S2 item 1 1, item 1 2 5, and item 3 4. We find that item set as is a match with you, and so the addition item process in S1 is recommended to user with predictive value 5. Now the aforementioned problem are solved, but my algorithm should be enhanced. Suppose that the number of fluid item set is huge, and each item set has also a lot of items. When we match a rating vector with fluid item set, there There will be a bump up combination that may cause the computer system to be collapsed for all consumes much processing time. Therefore, I propose an enhancement method for matching, but based on bit matching technique. Certain 211 bit representation and bit matching. Simple writing vector frequent item set contains the four item, and each item has five possible rating values. I use the bit set whose length is 20 bits, so-called 20 line bit set to represent such rating vector for frequent item set. The bit set is divided into many clusters or groups. For example, if each item has five possible rating values, that each cluster has 5 bits. So each, each cluster represents a sub-item, and the position of a bit in each cluster indicates the creating value of corresponding sub-item. If a cluster contains a bit with a set bit 1, its corresponding sub-item is created with value with the position of such bit set of such set bit. Table 3 shows an example of bit set. Note that the bit set is similar to the bit vector proposed by author Dong Han Song et al. And dynamic bit vector proposed by the author Võ et al. Table 3 bit representation. For example, writing vector use item 1 3, item 2 5, item 3 2. It can form into use item 1 3, item 2 5, item 3 2. We represent it as a user as a bit string use here. Having the for cluster 1 2 for 1 2 3 4 for cluster. The frequent item set at 1. Item 1 3, item 2 5, item 3 2, item 4 5 is represented as 1 bit string. The frequent item set at 2. Item 1 1, item 2 5, item 3 4 is represented as 2 bit string between S2. In order to match S1 or S2 with use, we need to do n bit operation between S1 or S2 and use. If S1 and use equal use, then S1 matches with use. Otherwise S1 and use different from you, then S1 does not match with you. When S1 get matched with you, we do n not operation to extract items which are recommended to user. Simple the recommended item is denoted our item here, item S1, and not used here. From this bit set, it's easy to recognize that item 4 is recommended with read values is 5 because the fifth bit of the fourth cluster is set. I resolve my algorithm with concept of 3 following steps. Step 1. Writing matrix is transformed into bit creating matrix. Step 2. Bit creating matrix is derived from to extract frequent item set. Step 3. Writing vector and frequent item set are represented as a bit set. Bit matching operation are performed in order to find out the appropriate frequent item set with a matching with writing vector. Beyond such frequent item, it is possible to determine which items are recommended. Moreover, missing values of recommended items can be also predicted. Section 2.2 pseudo clock of for new algorithm for CF for new CF algorithm pseudo clock. And let the BS be created matrix, bit created matrix, and the set of frequent item set battery. And let match item set and our item be to match item set and recommended item with battery. And let bit set and cross be function that transform item into bit set and cross the number of bit 1 in the bit set with battery. And let bit transforms be the function which transform writing matrix into bit writing matrix. And let mining frequent item set be the mining function which extract frequent item set from bit writing matrix. See subsection 311, 312. Following is the pseudo clock line C language for my CF algorithm. We know that writing matrix is and recommended item are input and output of algorithm with battery. Step 1 and 2 are specified at clock lines 1 2. Step 2 is specified by specified at from lines 3 to 14. And line 3 to 12 is read how to determine 3 to 12. I read how to determine optimal frequent item set denoted match item set, and last 1314 express how to extract recommended item from matched item set. 1314. 1314. The second step, mining fluent item set from bit matrix is the most important since it is the core of the robust CF algorithm. Therefore, the question how to extract fluent item set from braided matrix will be answered in section 3. Section 3 mining fluent item set. This is also the main content of my research. My mining fluent item set method. My mining fluent item set method is based on the assumption the larger the support of an item is, the higher is likely that such item occurs in some interest in item set. In other words, items with high support tend to combine together so as to form a fluent item set. So my method is the heuristic algorithm called the Kroner algorithm. The basic idea is oxygenated form. By what task? Suppose you imagine that there's a one and there is a dataset rated matrix contains all items. Such dataset models as this one. On the one, all items are shown in descending ordering of their box. It means that the higher fluent item is followed by the lower fluent item. Moreover, we have a runner and we run it on the one from item to item with respect to the descending ordering. If an item is found satisfied at the minimum spot bishop, it will be added to the fluent item set, and the current task is continue until there is no item that meets the minimum spot. In the next time, all items in this fluent item set are removed from the one, and the next runner task will be performed to find out new fluent item set. My corner algorithm includes four steps. Step 1. Computing the spots of all items and arranging this item on the wall according to the descending ordering of their spots. Note that all items whose spot do not meet minimum spot means are removed from such a descending ordering. The kept items are called the fluent items. Of course, the first item in this descending ordering gets maximum spot. Step 2. The item set I from 1 to n is initialized by the first item in this descending ordering. The spot of our item set is initialized at the spot of this first item. The current item now is the first item and it will be removed from descending ordering. Step 3. If there is no item in descending ordering, the algorithm will be terminated. Otherwise, if the current item is the last one in descending ordering, then all items in the item set are removed from the descending ordering, and the number is increased by 1 is equal is at 1. Go back step 2. If the current item is not the last in the descending ordering, then the next item is bit, and so the current item now is the next item. Step 4. The support of the item set did not support item set is accumulated by the current item. It is the crowd of the total transactions contains on item in the in both the item set and the current item. If the support item set is equal or larger than minimum support, current item is added to the item set. Go back step 3. Step 3 and 4 are similar to what task which cross the item set model as the runner. After each iteration, such item set get thicker with more items. Section 3. Mining fluent item set. This is the runner algorithm. And let I1, I2, IM, and S be a set of items and a set of fluent item set respectively, and let C be the list of items whose spots meet minimum spot means are and are sorted according to this descending ordering. C is contained in I, and let SI be the item set, and let C be the current item, and let future minimum spot be the function that future items whose spot are greater than or equal to minimum spot, and let sort first, next, last be sorting getting first item, getting next item, getting last item function. Respectively, for instance, either pseudo-code language for runner algorithm programs a function mining fluent item set with not that the set of items I and the set of fluent items S are input and output of such function. Respectively, according to step 1, on fluent items are sorted at code lines 1, 2, 1, 2, 1, 2. And the item set initialized at like 5, 6, 5, 6, according to step 2. And last 8, 11, 8, 11, from 8 to 11, express that if current item C is the last one, then the item set is completed, and each item are moved from C according to step 3. And like 13, express that the next item is big, and it becomes the current item according to step 3. And like 14, M to calculate the support of the item set accumulated by the current item according to step 4. And given lines 15, 16, the current item is added to the item set if it satisfies minimum support. Although the runner may ignore some fluent item set, but it runs much faster than traditional mining fluent item set method. Especially, runner algorithm can be enhanced by using bit mining technique. Subsection 3.1 bit mining. When data matrix is transformed into bitcoin matrix, item and item set becomes cluster sub-item and bit set with battery. The support of item and item set is the number of bits whose values are 1 and bit set given medium support 2. Table 4 shows fluent item extracted from bit matrix, so in table 2. Table 4 fluent item set given medium support 2. In step 2, sub-items are sorted according to the descending ordering of the support, and some sub-items not satisfied meaning support means sub are removed given the minimum support is 2. Now sub-items are represented as bit cluster: item 25, 1111, item 13, 112, item 32, 110, item 45, 110. In step 2, the first item set S1 initialized as the item 25, that is the first item in the ordering S1, 111, and support S1 is the count of 111 equal 3, and where support denotes the support of item set and count indicate the number of bits whose value are 1 in bit set. In step 2 and step 3 and 4, sub-item cluster such as item 1, 2, item 3, 2, and item 4, 5 are big in turn, and on of them satisfy minimum support. Bitkin item 1, 3 support S1, 2. Bitkin item 3, 2 support E2. Bitkin item 4, 5 support E2. Finally, the fluent item set is S1, 110, which includes item 25, item 13, and item 32, item 45. We recognize that the bit set of fluent item set names S1C accumulated by fluent item after each iteration. This makes algorithm run faster. The cost of counting bit set and buffer bit operation is not significant. Subsection 3.2 improve runner algorithm. Runner algorithm may lose some fluent item set in case that some fluent items don't have so high support. They are not essential items, and they are in the last of descending ordering, so they don't have a major chance to solve the fluent item set. However, they could contribute themselves into some fluent item set because they can combine together to build up a fluent item set, but they do not match the support of a set item with green. But it is difficult to discover their usefulness in order to overcome this drawback. The corner algorithm is modified so that useful items are not ignored. So it's step 3. Instead of choosing the next item as the current item, we can look up an item whose support is pseudo maximum, and choose that item as the current item. The concept of pseudo maximum is defined later. The runner algorithm improves by modify step 3 and 4 defined in the next line. The runner algorithm is improved by modify step 3 and 4. I follow step 1 is the same to that of normal runner algorithm. Step 2 is the same to that of normal runner algorithm. Step 3, if there is no item in descending order, the algorithm will be terminated. Otherwise, If the current item is the last one in the descending order, then all items in the item set are removed from the descending order, and the number is increased by 1. Go back step 2. If the current item is not the last in descending order, we look an item come in the we look an item come up in the ordering, so that said item can combine with and bit operation with the item set so as to from the new item set to support a maximum as satisfies a minimum support. So they come called pseudo maximum support item is chosen as the current item if it exits. If it is not, if it does not exit, the current item is null. Step 4. The current item is added to the item set if it is not null. If it is not null, go back step 3. Go back step 3. The next line defines the pseudo line language for improved runner algorithm grabs a function mining print item set which not that the set of item I and the set of print item set as are input and output of such function repeatedly. Improvement of runner algorithm. Following is the pseudo language for the improved runner algorithm. Program as the function mining print item set with not that the set of items I and the set of fluent item set as are input and output of such function repeatedly. Cognize 9 from 9 to 19. From 9 to 19. Find down pseudo maximum support item according to step 3. Cognize 24 add such item to the item set. The improved runner algorithm takes more time than normal runner algorithm for looking up pseudo maximum support item in step 3, but it can discover more print item set, so its accuracy is higher than normal runner algorithm. Session 4: Evaluation and Discussion. As aforementioned in the introduction session, the most significant feature of the robust algorithm is the simplicity with grounded bit sets, which relates to bit representation. If rating values are decimal numbers, is required to convert decimal numbers to integer numbers in use of robust algorithm. For example, if rating values runs in real interval 0, 1, then values 0, 0.15, and 1 are converted to 0, 50, 100 repeatedly, given integer interval from 0 to 100. The bit representation will use storage space. For instance, database needs at least 240 bits to store ratings for 3 items and 10 users because each value needs 1 byte a bit, whereas it only requires 150 bits with bit representation given integer interval 1, 2, 3, 4, 5. In other words, service storage is a strong one of robust algorithm. Database movability is used for evaluation. It is divided into 5 folders, and each folder includes training set over 80% host database and data set over 20% host database. Training set and content set in the same folder are disjoint set. The system setting includes processor Intel, dual cores, RAM 4 GB, Microsoft Windows 10, Windows 10 Pro, Java 8, and Java 8. My robust algorithm named Green Font. Green Font is compared to 3 other algorithms: neighbor item based, neighbor user based, and FPD. These algorithms are implemented on the infrastructure Hadoop. Note that Hadoop is a middleware framework for a commercial recommendation software, which is both scientists and software developers to build up their own recommendation algorithms with low cost, high achievement, and fast speed. Hadoop is accepted by European release base, whose trial version is available at here. Such algorithm follows redefined specification so that evaluation mechanism of Hadoop can custom according to standard metrics. There are 7 metrics used in this evaluation: MSE, precision, recall, F1 rebound time and setup time. Rebound time matrix which measure speed of online recommendation process is calculated in seconds. Setup time matrix which measure time consuming of offline modeling process training process is calculated in seconds. Evaluation and discussion. MEA's MSA, abbreviation of absolute and mean square error, are average absolute and square deviation between predicted rating value and user two ratings. Hence, MEA's MSA are predictive accuracy metrics. The less they are, the higher accuracy is. They are calculated by equation 1 and 2, which S is the total number of recommended item where Y, BI, and VI are predictive rating and true rating of itemized respectively. Resistance recorded at F1 are quality metrics that measure the quality of recommendation list, how much the recommendation list reflects user preference. An item is relevant if its rating is larger than or equal to average rating. For example, with the rating question range 1, 2, 3, 4, 5, the average rating is 3. The larger quality matrix is, the better algorithm is. An item is selected if it is recommended to user, and let an NRS be the number of relevant items, and let NS is the number of selected items, and let NRS be the number of items which are relevant and selected. According to equation 3 and 4, resistance is the ratio of NRS to NS, and recourse is the ratio of NRS to NR. In other words, resistance is the probability that selected item is relevant, and recourse is the probability that relevant item is selected. F1 is gradual combination of resistance recourse and given equation 5 here. Table 5, evaluation result on database movement 100K. Table 5 show the evaluation result of database movement 100K contains 100,000 rating of 943 users on 1,682 movies and are split into 5 folders. The setup time of neighbor item base and user base item base is 0 because the algorithm are memory receipt and they do not have internal modeling process. As a result, my algorithm is more effective than other algorithms when it gets high quality with matrix resistance record F1. Its quality via F1 matrix is 56 times 98.5 times and 34 times better than item-based, user-based, and SVD respectively. The reason is that it makes a recommendation based on driven item sets which represent users' interesting patterns. However, its accuracy is lower than item-based and SVD with matrix MAE, MSE. Its MAE matrix is 1.4 times and 1.45 times worse than item-based and SVD respectively. The reason is that it does not do arithmetic operations like addition, multiplication, and estimating missing rating value. In general, accuracy is strong bond of SVD. Author Roboso 3 improve variant of SVD. Should I RSVD2 with S2 by SC to the gradualized SVD canon with both processing SVD with KNN with K nearest neighbor similarity and SVD KR with both processing SVD with chronocrystal regression. The author Peter evaluates these various of Netflix price database will result that the MSE of the method based SVD, SVD2, SVD KNN, SVD KR are here. Respectively, until Netflix price database is different from moveless database, the evaluation result of the author Bartolet assert the eminence of SVD with regard to accuracy in recommendation. Therefore, what is just the eminence of my algorithm. Moreover, it will much faster than other methods. It reborns 1,870 times, 1,637 times, and 2 times faster than item-based user-based and SVD respectively. It is not dominant over SVD in response time, but its modern process consumes this time according to setup time matrix, which is 51 times faster than SVD. It consumes it consumes less memory because storage capacity of fluent item sets is insignificant, whereas SVD requires a larger amount of memory to store the composed matrices. In fact, mining fluent item set is faster than learning the composed matrices. Figure 1 shows comparison between the robots algorithm and SVD. My robots algorithm and SVD, which is class 2 matrix MEH F1 setup time response time given database movement 100K. Figure 1. Figure 1 comparison of the robots algorithm and SVD given database movement 100K. When database is enlarged with much more rating, given database movement contains 1 million rating, 1M, memory-based CF algorithm are user-based and item-based cannot conquer the global algorithm and everyday keep their execution stable. The robust algorithm is dominant over SVD in quality of recommendation and modern process. Table 6 shows the evaluation result on database movement 1M. Evaluation result on database movement 1M. Its quality via F1 matrix is 37 times better than SVD, whereas its accuracy via MEH matrix is 2.44 times worse than SVD. Its setup time is 16.65 times faster than SVD, while its response time is 0.82 times approximated to SVD. The reason is that it does bitwise operation on both the offline modeling process and online recommendation process. The cost of this bitwise operation is low, regardless of database volume. Figure 2 shows comparison between the robust algorithm and FVD given database movement 1M. When comparing two result on database movement, it's extended from 100K to 1 million. Recommendation quantities is dominance of the robust algorithm because its F1 scale is increased from 34 times to 37.08 times better than SVD. In general, the robust algorithm is appropriate to fast and high quality recommendation application. When customer purchase patterns are concerned most, it can mine the fluent item set regardless of missing rating values, and so the program of spare matrix of aforementioned in the introduction section is shown. Figure 2. Comparison between robust algorithm and FPD given database movement 1M. Conclusion. MyCF collaborative algorithm is different from other model-based CF algorithm when trying to discover user interest. The mining technique is important for extracting fluent item set considers a pattern of user interest. However, traditional mining algorithms consume much more time and resources, so I proposed a new mining method, a so-called coroner algorithm. Based on evaluation measure, runners improved a reliable algorithm with high performance, fast speed, high quality of recommendation, and consuming less time and resources. Its drawback is that it may ignore some interesting patterns because of heuristic assumption. However, this drawback is alleviated by taking advantage of enhanced technique with concept of pseudo maximum spot. In the future, I will propose another model-based CF algorithm which applies a Bayesian network into inference user interest. Such algorithm based on probabilistic inference will be compared with the mining approach in this paper so that we have an open and objective viewpoint about recommendation study. Acknowledgement. This research is made to acknowledge Sir Vũ Ngọc Đồng, who gave me valuable comments and advice. The comments helped me to improve this research. This is reference, and also reference. There are 22 reference. Thank you very much for your listening and attending. I'm very honored and happy to answer all of your question. Answer your question from all of you. Many thanks to all of you again.